A phased array system uses a method called beamforming, in which multiple antennas basically change the time at which the signals they receive are combined together. So if you can imagine, you have several antennas along my arm, and you have a radio wave coming down like this. It's going to hit this antenna, then this antenna, then this antenna, and so on. You basically do a time delay, and you shift the signals that are received to be in what's called in phase. By changing that time difference between each of the antennas, you're basically taking the antenna where it's looking and steering it like this. Our system not only can do one-dimensional, it's a 2D array, so we can go in any direction we want.
That's the big challenge with these. They typically are digital systems that utilize really expensive analog to digital converters.
We decided to use a bit of an older style of beamforming where we do not digitize the signal at all, meaning we can cut out those analog to digital converters and drastically reduce the cost of our system.
Some of the biggest challenges with our project were learning how to develop a system from the ground up. We had to utilize knowledge from courses that we'd previously taken.
Many of us had actually met in a class called 309. From there we had worked together fairly often, so I was fairly comfortable with the people that I would be working with. I had also heard that a member of our team had actually brought in this project personally from an internship he got from a company called Blue Halo, and he seemed to inform us all that we were going to get fantastic company backing behind this project, and we certainly did. They were absolutely fantastic.
I think that the team was a good fit. I think that we had a great advisor. She helped us mainly with documenting our progress, which made the latter part of the project a little bit easier when we had to communicate what we had done, which is typically challenging for engineers. We can make really complex designs, but a lot of times it's really difficult to communicate the facts without getting in the weeds. So we were able to do this design and then communicate well exactly what we had done.
We were definitely able to solve our problem. Our system costs about as much as what a single analog to digital converter for our frequency band would cost. For that, we have 16 antennas and are able to steer 30 degrees by 30 degrees, which is, for a phased array system, is pretty good.
I've always taken the RF classes here as technical electives. It's sort of like a black magic world. You can't see any of it, but a lot of really amazing stuff happens, and it's sort of like the basis for a lot of communication systems and a lot of the technology we utilize today. So it was really cool to utilize or realize a technology that helps us communicate and live our daily lives.